Hi folks, welcome back to the second part in the lecture videos for 10.5 polar coordinates. So in this section we're going to focus on converting between polar and rectangular equations. So if you haven't watched video 1, I'd pause here, go back to video 1 so that you can get an understanding of converting between polar and rectangular coordinates. Alright, so let's go ahead and write down some important equations that we're going to need. So we need to remember that r equals our x equals r cosine theta, and y equals r sine theta. But we also need to remember that r squared equals x squared plus y squared, and that theta equals the inverse tan of y over x. And we're going to use those four equations to help us convert between polar and rectangular equations. So let's take a look at example 5. It says find the polar equation for x squared plus y squared equals 9. Now by now we should know that this is a circle with a radius of 3 based off of the lesson in 10.2. And now we're going to look at how we can convert it to its polar form. So to convert it to its polar form, we're going to do some substitutions. Instead of x squared, I'm going to write r cosine theta squared. Plus, instead of y squared, I'm going to write r sine theta squared equals 9. And now I'm going to expand. R squared cosine squared theta plus r squared sine squared theta equals 9. And I'm going to factor r squared out, and I'll get cosine squared theta plus sine squared theta equals 9. Now, in here, we should be recognizing that Pythagorean theorem, this goes to 1. Cosine squared plus sine squared equals 1. And that's helpful for us because that means r squared equals 9. And what that means is we can say that r equals 3 is one equation, or another equation we could call it is r equals negative 3. Okay? I think by convention we tend to pick the positive one because it means how many circles we're counting out in the direction that we're in. Okay? But r equals 3 is the polar form of a circle equation. All right, let's take a look at question number 6. So question number 6 says find the polar equation for x squared plus y squared equals 6y. Now I'm going to take a little bit of a shortcut here. We might notice that r squared is equal to x squared plus y squared. So everywhere I see an x squared plus y squared, I'm just going to replace it with r squared right off the bat. So I'm going to get r squared equals 6, and instead of y, I'm going to write r sine theta. Okay? That will give me r squared equals 6r sine theta. And because I see a square, I'm going to move everything to one side so that I can set it equal to 0, and then I can factor. Okay, it's really important when we're solving quadratics that we move everything to one side because the other side has to equal 0. All right, now we're going to set each piece equal to 0. Okay, and we're actually going to get rid of this one because this is just a single point at the origin, whereas this other part will actually give us an equation. So this equation ends up being r equals 6 sine theta. Okay? All right. Let's move on to example number 7. So example number 7 is one last question in practicing converting a rectangular equation to a polar equation. So let's see what we can substitute. Well, everywhere I see a y, I'm going to replace it with r sine theta. And everywhere I see an x, so instead of 3x, I'm going to write 3 r cosine theta plus 2. And now I'm going to distribute that. So I'll end up with r sine theta equals 3r cosine theta plus 2. And I'm going to subtract all the terms with r to the other side. So this is going to move over here. R sine theta minus 3r cosine theta equals 2. And now I'm going to factor out the r. So I get r parentheses sine theta minus 3 cosine theta equals 2. And the nice part about that is I want to get r by itself. So all I need to do is divide. So I get 2 divided by sine theta minus 3 cosine theta. And that's it for my polar equation. Okay, so now let's take a look at 2 examples that ask us to go the other way. We're going to have our polar coordinate and we're going to go backwards to find our rectangular equation. So in this case, I'm going to take this equation, I'm going to go ahead and take this new denominator and multiply it to the other side. So I'm going to get r times 1 minus 2 cosine theta equals 3. And now I'm going to go ahead and replace this cosine theta with a version of what I already have. And what I mean by that is that x equals r cosine theta. It also means that x divided by r equals cosine theta, because I just divide the r to the other side. So everywhere I see the cosine theta, I'm going to put x over r. That's going to give me r times 1 minus 2 x over r equals 3. And now I'm going to distribute and distribute. So I'm going to get r minus 2xr over r equals 3. I know that I can reduce those r's. And I get r minus 2x equals 3. And so I'm going to say that r equals 2x plus 3. All right, so I just added that 2x to the other side. Now what I'm going to do is remember that another way of saying r is that r squared equals x squared plus y squared. But what that means is r equals the square root of x squared plus y squared. And so instead of r, I can write that the square root of x squared plus y squared equals 2x plus 3. And I know it's a little weird for us not to have equations solved in terms of y, but technically there's nothing wrong with this. You could also square both sides and you'd get x squared plus y squared equals 2x plus 3 squared, and that would also be okay, all right? But it doesn't mean that you're always trying to figure out what y equals. You can sometimes leave it in this form, and this type of form is called implicit form. All right, let's do one last example of converting equations. So we're going to take this rectangular equation, or polar equation, r equals sine 2 theta, and we're going to go ahead and try and convert that to a rectangular equation. So I'm going to use one of my trig substitutions that we learned back in the earlier chapters, that sine of 2 theta is the same as 2 sine theta cosine theta. And the nice thing about this is everywhere I see a cosine theta, I can replace it with x over r. But similarly, everywhere I see a y, or everywhere I see a sine theta, I can replace that with y over r. Okay? And the reason I can do that is because y equals r sine theta, which means that y over r equals sine theta. So let's see what these substitutions do. r equals 2 y over r, x over r. And when I clean this up, I get r equals 2xy over r squared. Now I'm going to go ahead and multiply this r squared to the other side, so I get r cubed equals 2xy. And I'm almost done. I have some x's and y's, but I need to get rid of that r on the other side. And so what I'm going to do is make a substitution using this, that r can equal the square root of x squared plus y squared. So I get the square root of x squared plus y squared, squared, not cubed, cubed, because that's r cubed, equals 2xy. And this is a fine form to leave your equation in, but if you prefer, you can certainly write it as x squared plus y squared to the 3/2 power equals 2xy, and that would also be fine. All right, so in the last few moments of this video, what we're going to do is take a quick look at Desmos, because I think Desmos will be really helpful in the graphing of polar equations in this next video, okay? So let's take a look at Desmos. So a few features that I want you to be aware of in Desmos are as follows. If you go up to the little wrench in the right-hand corner, and you click on the circle grids, that will give you polar coordinates, okay? And now I can graph some things. So for example, let's say I want to graph r equals 3, okay? We found that answer earlier to be the same equation as x squared plus y squared equals 9, or a circle centered at the origin with a radius of 3, okay? So this is a good way for you to double check your answers as you're going, and I think you'll find it helpful if you can sort of explore some of the graphs with me in the next few videos. All right, so folks, I'll see you back here for part 3 of 10.5 polar coordinates. See you soon.